So it looks like I'm getting so it seems like
Oh, I've got this notes in my wrong section. Okay, here, let me just copy this. Whoops. Copy. And let's paste it into Chem 11 because this isn't really Chem 12. There we go. Control V. There we go. That's better. Anyone need another minute? We're good to go? Okay. Can I call on you?
preferably not.
Preferably not. Not even to draw like one of them? No? No? Come on. Like one of them's got to be really easy. If you volunteer, you get to do the easy one and you don't have to do the hard one. Yes, Annette. There's an atom, yes. And what does an atom look like? Just a circle, right? Because it's going to be a sphere, but we can't really draw a sphere without taking a lot of time. So we're just going to draw an atom. Yeah? We got a molecule. Now, molecule does have some subcategories. Molecule of ooh, I heard a word. Molecule of a compound. Oh, look at that. Now that you've got that, if you didn't have that before, see if you could draw a picture of a molecule of a compound. Can you draw a picture of a molecule of a compound? What's the other one? We got a molecule of a compound. We also have a molecule of
Element.
an element. Yes. Please try and draw a molecule of an element.
I'm assuming this is going to be on the test.
Heck yeah.
Molecule of an element. I'm going to just do
Yeah, I mean, a molecule of an element is really easy, right? Because all you got to do is pick one of your diatomics. Doesn't even matter which diatomic. That's the easiest one to draw. I mean, if I had to make a choice between drawing S8 or drawing N2, guess which one I'm drawing? I'm drawing N2 because I can be like, oh, look, N. Oh, there we go. They're both the same. If you want to draw S8, you're welcome to. I mean, you just have to draw them in a little octagon, but hard. I would find it difficult. I'd probably end up with like the wrong number and then I'd be like, oh my gosh, I've got 7 only and I've run out of room. It would be so frustrating.
just chuck one in the middle.
Maybe, yeah, you know, like, anyway, stick with one of the diatomics. It makes it easy. Molecule of a compound. How would that look different? Yeah.
Like 2 different types of atoms.
Yeah, 2 different types of atoms. So you might have N with an H and an H and an H. Can you think of another example?
CO2.
CO2. C and an O and an O. All right, I really did not leave myself enough room for this, so I might have to, like, actually, you know what I can do? I can grab this and drag it down. That's so smart. Okay, I'm gonna do that. There we go. All right. So we have an atom, that's easy. We have a molecule, molecule of a compound, molecule of an element. Third type of particle. Ion. And an ion has subcategories. In fact, there's two different subcategories you could classify it. You could classify them one way, or you could classify them a different way. Yes, although it's pronounced cation. Yes, cation.
Caution.
Caution. Yeah, exactly.
Oh wait, no.
No, it's cation. Because cats have paws, so cations are positive. What else do you know about cations? Tell your partner anything else you know about cations. Ooh, I heard it. Yes, they're usually metals. I say usually because sometimes we have another type of ion as well. That'll be in our second categorization, okay? So the other category from cation is? Anion, yes. Onions make you cry, which is negative. These are usually nonmetals. However, we could categorize these a different way. I'm going to call this A prime and B prime, okay? That's what that little dash stands for. It's a prime, and it just means another A and another B. Anyone got any ideas?
What's the first line? What's the first line? First two letters. M. I was gonna say Chicano. Oh, P. Oh. Oh, wait. What's the next letter besides M? What is your way? Okay. It's not molecule.
Ooh, yes. What was that? Monatomic.
Oh.
And the other one would be polyatomic. Okay, so we have monatomic and polyatomic. Could you draw a monatomic cation? Ooh. What does mono mean? One. So how many atoms? One atom. And if it's a cation, what type of element should it be?
Metal.
Should be a metal. So what would it look like? Think of an example. You may use your green periodic table. Find your green periodic table. What did you say? Na plus. So we're going to have Na plus. Can someone give me a different monatomic cation?
Calcium.
Calcium. What's the charge of calcium? Is this column 2? 2. What's the charge of all the ions in column number 1?
Probably 1.
1. What's the charge of all the ions in column number 2? 2. Okay, now you know always column number 1 is plus 1. Hang on. What's the charge of all elements in column number 1?
1.
1. You will not get charges on your periodic table this year. Okay? It's coming up.
What if I write my own charges?
You can do that, but it wastes your time if you can just know them in your head. Do you know what I mean?
Yeah.
Like, I have no issue with you writing them, though. That's fine. Because I know some people are like, I'm going to have a panic attack if I just don't just get them right down right away. And that's okay. You can definitely do it. All right. So a cation, calcium is in column 2. Therefore, what is its charge? Plus 2. So we could have Ca 2 plus. Monatomic anion. Tell your partner what you could have for an example of that one. Feel free to use your periodic table.
Oh, Miss Beth, when do you use like the little brackets? Like the square brackets?
Yeah, I'll show you.
Is that when you like draw multiple things? Yeah.
Monatomic anion. Who could we use? What element could we use? We could use, carbon is if just based on what you know from past lives, like grade 10 and 9, past lives, you know, your former grades, carbon would be a yes, but I'm going to tell you right now that carbon does not tend to form ions. It tends to form covalent bonds only. So let's pick something that's not carbon.
Phosphorus.
Phosphorus. Okay, so phosphorus, and I don't expect you to know this right now, but it has a charge of 3 minus. Okay, phosphorus. Another example of a monatomic anion. Yes, Matthew. Fluorine. Yes. And I'm going to give you a couple of names here because we're going to be naming soon after break. This is it's not phosphorus anymore. Its name is phosphide. Okay, anions take the name ide. And fluorine isn't fluorine anymore. It is named fluoride. That's why you have sodium chloride. And watch out, I'm just letting you know right now, fluorine is hard to spell. And I will give you a half a mark off if you don't spell it correctly, because it will be in front of you because it is on your periodic table. Okay? You can literally be like, fluorine, I know I have to copy it down because maybe I'll make a mistake. It's UO, not OU. So fluoride, not fluoride. Okay? All right, those are our monatomic ions. What if we had a polyatomic ion. You don't have to give me actual polyatomic ions. You might not know any of them at this point, but if you do, you can let me know. Polyatomic cation. What would that look like? You don't need to know specific elements, but what would I do? Poly means many. So how many atoms do we have? Many. In other words, more than 2, or 2 or more, equal, greater than or equal to 2 atoms. Does anyone know a polyatomic cation?
Hydroxide one.
It's negative. There's not very many, to be honest with you. So if you were to draw anything, like if you were to draw, you're like polyatomic cation. All I know is that I need more than 1 atom stuck together. And what does it need to have? Needs to have a positive charge. And so this is where we would use the brackets and we would put the plus. Okay? That's just a generic polyatomic cation. I don't think that one even exists, but that's okay. What about a polyatomic anion? What would I draw? Would I draw 1 circle or 2 circles or more? 2 or more. Let's do more this time just to make it different, okay? Okay, so there's more, 2 or more. And because it is an anion, what else do I need? I need a negative charge, so I'm going to put brackets around it and put negative. Okay, or I could put -2. Yeah, if I wanted to. Draw an ionic compound and give an example of an ionic compound. Show your partner what you drew for that one. If you haven't done it yet, do it now.
Salt.
Give it a try.
Salt.
Oh, we're not done yet. Because we only got how many? We only got 3. Oh, oops, I'm rushing ahead. One, 2, 3. All right, what's our 4th one? I keep needing to move this poor ionic compound down. It's like, no, leave me alone.
Yeah, I'd be rich if I was a
There we go.
Salt.
Okay. So we have atom, we have molecule, we have ion. 4th type of particle. Formula unit. Yes, so we have atom, molecule, ion.
Oh, we're done.
And the 4th one is a formula unit. What should we see for a formula unit?
Got 2 circles.
2 circles, okay. Is that it?
Yeah, add a minus and a plus. So.
Maybe add a minus and a plus. Yeah. Okay. To be honest with you, it could be this, or what if I had a 2 minus? What would I need to do? I would need to have a plus and a plus, or I could have a 2 minus and a 2 plus. What if I had a 2 plus? What else could I use? I could use a minus and a minus. How did I know? How did you guys know how many to put? What is the overall charge? Overall charge is 0. It's neutral. Okay. Oh my gosh, have we finally made it to draw an ionic compound? I might have to make it a little bigger. It looks like puny now because I think I started writing bigger. Okay. Have you successfully drawn an ionic compound? How many people feel I'm not going to call on you, how many people feel they may have successfully drawn an ionic compound? 3 of you, 4 of you, 5, 6, 7, 8, 9. Okay, all right, well, at least half of you. That's good. What kind of compound is this? That is an ionic compound. Okay, but when we actually draw an ionic compound, we're going to go a bit more in depth because we can't really have a single formula unit all by itself. What do we have instead? We have a crystal lattice. And what does that look like if you had to draw it? Small, big, small, big, small. You can make it as big as you want to. And then what should the next row be? Opposite, big, small, big. Oh, I've drawn that badly. Not very good at this drawing business. Small, big, small, big. Small, big, small, big, small. That looks like enough to me because I can't draw anymore. And what would I put in the small ones? Positives. If you get that backwards, I'm not going to get too upset at you at this point. But if you can remember it, that would be awesome. I might give you an enriched mark for knowing which one is which. Positive is smaller. Okay, so that's our crystal lattice. Give me an example of an ionic compound. Yes.
NaCl.
NaCl, sodium chloride. All right. So this crystal lattice, a formula unit is an ionic compound. A crystal lattice is an ionic compound. What's the other type of compound? Tell your partner. There are ionic compounds and there are covalent compounds. Where in here would I find a covalent compound? Do you see any covalent compounds here?
CO2.
Cl2?
O2.
Okay, hang on. Is Cl2?
Oh, I meant CO2. CO2.
Huh?
I said CO2.
You said CO2. Oh. Is CO2 a covalent compound? Tell your partner what you think. Do you think CO2 is a covalent compound?
Probably. Oh, watch the big movie. She just said no. My phone. Well, it says protein shake, but it tastes really good. I don't know. It's like
What kind of an element is carbon? Look on your periodic table. What kind of element is carbon? Non-metal. Carbon is a non-metal. Yeah? Yeah? Okay. What kind of an element is oxygen? Non-metal. So is CO2 a covalent compound? Yes. Is Cl2 a covalent compound? Yes, Rajan. It's not a compound. Because both of the atoms are the same. So CO2, if you had to draw it, that would be an example. Oh, that's such a terrible circle. So sad. I can't even blame the pen for that one. That's just all me. Oh, there we go. Okay, so that is a covalent compound. Cl2. Not a covalent compound, but what kind of bond is there? What type of bond between C and O? Yeah, it is a covalent compound, therefore it is a covalent bond. Tell your partner, please, what happens with the electrons in a covalent bond? Yeah, in a covalent bond, electrons are shared. What type of bond is between the Cl and the Cl? What type of element is Cl? Go look on your periodic table. What type of element is Cl? Non-metal. What type of element is Cl? Oh, hard question. Non-metal. What type of bond forms between nonmetals? Covalent bonds form between nonmetals. Always. Okay, there's one exception to that. So if you've got a polyatomic ion and a polyatomic ion, you can get an ionic bond between the polyatomic ion and the polyatomic ion, but that sounds too complicated for right now. Okay, so we're just gonna pretend I never said that. Did you guys catch it? No, good, excellent. Pretend it never happened. These are not the droids you're looking for. All right. Where did we go now? Where shall we go? We shall go, I'll give you a minute to finish writing. Is this useful? what we're doing right now? Yeah, okay. Because there's lots of different ways to give you practice on the math stuff, right? But it's hard to come up with worksheets full of questions on covalent compounds and ionic compounds and, you know. All right, back up here to our crystal lattice. What type of bond?
Ionic bond.
Ionic bond, because guess what? It's an ionic compound. Therefore, it is an ionic bond. What type of element is that negative ion?
Metals.
What type of ion is metals form positive ions, non-metals form negative ions. Think about it this way. Non-metal starts with N, negative starts with N. Yes? So non-metal is negative, and the metal is going to be positive. Is this thing a pure substance or a mixture? Pure or mixture?
Pure.
It is pure because it is a compound. Every single formula unit is the same as every other formula unit. Okay, what else do I want? Yes. Two last questions. Are all molecules compounds? Explain. If not, give a counterexample. Do you guys know what a counterexample is? A counterexample is an example that proves it wrong. Okay? And the second question, can you guess what it is? Are all compounds molecules? You have to think about it now. Explain. If not, give a counterexample. Once you have written your own answer, show your neighbors. All right, let's vote. We're going to vote for the first one. For number 1. Are all molecules compounds? That's a yes, a no, and I don't know. No, they are not. Could you please give me a counter example? Yes. O2. O2 is a molecule that is not a compound. What is it instead of a compound? It is an element. Are all compounds molecules? Oh yeah, you guys are still writing. I'll give you a second. Are all compounds molecules? Yes, no, I don't know. Oh yeah, yeah. Okay, I got a mixed bag on this one. A bunch of people who aren't voting. I don't know why they're not voting, because there is the I don't know option, which is perfectly good. Okay, the answer is, if I can get this pen to write, just a second here. The answer is no. Neither of them are correct. What is a counterexample that proves that all compounds are not molecules? Yeah, any ionic compound form crystal lattices, not molecules. And so, for example, you could say, what's an example of an ionic compound? Pick a metal, any metal. NaCl, what's another metal? Platinum, ooh, let's have platinum 4 oxide, PtO2. Okay, that is platinum 4 oxide. Do you guys remember your Roman numerals? See if you can write your Roman numerals. That's another unit that's coming up. You don't need it for this test, but just see if you can remember them. Can we do number 1? 1 is just I. 2 is I. Captain. 3 is I. And 4 is IV. 5 is V. 6 is VI. 7 is VII. And 8 is VIII. That's going to come up in unit 4, not this unit, unit 4. Oh, and while we're previewing unit 4, why don't we preview our prefixes? And I'll start you out with number 1, which is mono. See which ones you can remember.
4. Five. Oh, what was 5? It's a wiggler.
What do they call this if you're a witch?
A star.
If you're a witch, they call it a pentagram, yes?
6 means
I don't know why.
it's like that shape. 6 of them.
Yeah, and then what's this shape?
That's a great question.
This is a pentagram.
Let's say hologram.
1, 2, 3, 4, 5 sides is a pentagon. So what's 1? Mono. 1 is mono. 2 is di. 3 is tri. Did anyone remember 4? Tetra. Anyone play Tetris? All the little blocks are made of 4 squares. Did you know that? Tetra. All the little blocks are made of 4 squares. Count them. And 5 we just went through is penta. What do we call this shape? 1, 2, 3, 4, 5, 6. That is a hexagon. So 6 is hexa. 7 is hepta. You're really close. Not septa, but hepta. Okay? So we have H and then H. And sometimes people get mixed up between the 7 and the 6. But remember, 6 also has an X in it. Hex 6. Yes? 8. Octa. And if you can't remember that, you can think of a 1, 2. Under the sea, baby, it's better down where it's wetter. Take it from me. You guys don't know the Little Mermaid? Yeah, some of you do. Okay, anyway, octa, octopus. 9, nana, and 10 is deca. You'll need to have those memorized this year. Not for this test, though. Again, unit 4. Not on this test. All right. So we have about 20 minutes left. Would you like some time to practice sig figs and conversions and various things like that? Or to do vocab if you prefer that? Or if you're like, hey, I could use a challenge. I've got some challenge stuff I can point you at. Okay? So let me know what you would like. Your test is when? Thursday. I'm thinking tomorrow we might start our new unit. Okay? Woo!
Oh, come on, man. Try it, please. No.
We're not going to finish all of workbook 2 because I just feel like it's too much. So we'll only get up to 2.6C. If you're like wanting to do a little practice on particles, you could try 2.6C.
Don't get hit. You just don't need to get hit right now.
Yeah. I'll give you a fresh one. How's that?
Oh, hold on. Oh, we're not good, Pat. You're gonna die. It's too down. Oh. Oh. We got time to clear that. 20 seconds. 2 things. Might be able to get. Okay. Gotta go a little faster.
I'm gonna put that out for you right now.
Run out of time. Oh.
Stop.